Namaskar my dear friends. Let's talk about power transistor that is there in NPN and PNP forms. So we'll talk about two transistors. One is tip 142 and one is tip 147. So one of them is NPN type and another one is PNP type. So our motive is to understand what are the different parameters or different specifications that is there in power transistors and where they are used and how to choose them, right? So with these two applications, we will be able to understand how we can identify a power transistors in a proper fashion. So basically you can see we have applications of power transistor in many applications, like we have linear and switching industrial equipments or something like this. So generally a power transistor will be in big package, like it will be in CAN package or something like that, CAN TO92 or something like that, even TO247 or TO218. Okay. However, from onsemi it has been told like TO218 will be discontinued and TO247 will be in progress, like it will be in continued fashion. So let's see the internal schematic that is there generally followed by power transistors. So as you can see, one of the device I have taken from STMicroelectronics, and in that it is Darlington configuration. Okay, so as you can see we have collector, base, emitter and base. So you can see one of the transistor is followed by another transistor, and you will see there are two integrated resistors R1 and R2. Their values are 5 kilo ohm and 60 ohms. So this is NPN type. Okay. Coming back to the PNP type. So if you talk about PNP type, we have the same configuration in Darlington schematic form. So Darlington schematic form is generally followed because of it has very high gain. Okay. And due to this high gain, we will be having achievement of higher IC current, right? So that will come around, let's say 10 amperes or something like that. So it's not that easy to achieve very high current gain in lower in single transistors. That's the reason they are going to come up in a form of Darlington transistors. Okay. Same kind of schematic is there from one more manufacturer. If we talk about, let us say onsemi device. So in onsemi device it is also the same fashion. One is NPN type, another one is PNP type. As you can see, we have other devices as well, like TIP 140, TIP 141, TIP 142. So basically the voltage ranges changes for each one of the transistors. Okay. So our main aim is to understand TIP 142 and TIP 147. Okay. The only difference that you can see from onsemi and this STMicroelectronics is these resistors R1 and R2 values are little different, which is R1 and R2. However, any of the manufacturers you can select, but our main aim is to understand how we can choose a power transistors. Okay. So let us open the data sheet of STMicroelectronics, which we can see here. TIP 142 and TIP 147. So this is my NPN power transistor and this is my PNP power transistor. Okay. Alright. So if we quickly see what are the different parameters that we need to talk about. So the thing is, first of all we have to understand this is complementary power transistors. Okay. And it is in Darlington form. It means you can directly like understand that it will be having high gain. And because of high gain you will have a capacity of coming to have IC will be around like 5 amperes or 10 amperes, even 20 amperes, something like that. So power transistor requires to have very high gain. Because of that they need very high current capabilities. What are the features that we have to talk about this particular transistor is, this is a monolithic Darlington configuration and it is integrated anti-parallel collector emitter diode as well. So as you can see, generally you will see in normal transistors which will be having single transistor, there will not be any integrated resistors or there will not be any freewheeling diode kind of thing. This is kind of freewheeling diode, right? So this is anti-parallel diode. So these two will not be available in normal transistor that we utilize generally for our switching applications. Okay. Alright, so let's quickly move to the features and all. So as you can see, we have part number tip 142 and tip 147. This is polarity NPN and PNP, and we have the package TO247. TO247 package is just because of it has a very high power capability. That's the reason we need to have a bigger package. Coming back to the absolute maximum rating, so any of the data sheet I have told you earlier, in the same fashion there will be an absolute maximum rating capabilities for each one of them. So what is the collector base voltage range? So that is 100 volt. Coming back to collector emitter voltage range, so that will be also 100 volt, right? So as you can see, a transistor, I am telling you like this, let us say a basic transistor configuration will be something like this. This is my base, this is my collector, and this is my emitter. So voltage range between these two will be 100 volt. Similar to that, between these two is also 100 volt. And what is the emitter base voltage? So emitter base voltage is basically nothing but this one. So this is going to be 5 volt. Okay. So generally our aim is to understand the base to emitter voltage will be 0.7 volt in normal transistors, but it has a absolute capacity of 5 volt, right? Now what is the collector current capability? So that is 10 amperes. If you talk about peak current capability, so that is can go up to 20 amperes, but that will be for limited times, let us say some 10 millisecond or something like that, or even 1 millisecond will be there, that will be given in the data sheet itself. However, this is peak value, this is not supposed to be a continuous current through the transistor. If you talk about base current is going up to very good value, which is around 500 milliampere, that is 0.5 amperes. Generally these are the ratings which is there in microamperes in normal transistors, and the total power dissipation capability is 125 watts. Okay, so let us say we have a system of, let us say 24 volt, then it can go up to like 5 amperes of current through the collector to emitter. So that's how you can spend around 120 watts of power. So it is up to, let's say 12 volt like system, then we can go ahead with 10 amperes rating of the current. So this is how the power dissipation across the transistor is taken into account. The maximum operating temperature of this particular transistor will be up to 150 degree centigrade. Similar to that, for PNP type, voltage and current ratings are actually negative because the current goes from emitter to collector, and here in NPN it is going from collector to emitter, right? So collector to emitter in NPN, and in PNP there will be emitter to collector. So PNP, what is the symbol? It is like this. This is my collector, this is my emitter, this is my base. So current will be flowing like this. So that's the reason CBO CEO if I want, so CEO will be opposite, that's how it will be negative, right? Coming back to the thermal resistance, so thermal resistance for this particular device is 1 degree centigrade per watt. It means for each watt, like 1 watt of power dissipation across the device, there will be 1 degree centigrade temperature increment. So that's very good one. Okay, let's go into the recommended rating. So this is kind of electrical characteristic that we supposed to have across the device. So we have collector to collector cutoff current, that is nothing but so it's kind of the leakage current which is going to be ICBO, that is collector to base current, that will be in cutoff mode, that will be up to 1 ampere 1 milliamperes. Similar to that, collector cutoff current will be it is nothing but ICEO, that is collector to emitter base collector to emitter junctions, so that will go up to 2 milliamperes. Okay, and similar to that, in emitter to base junction it will be 2 milliamps. Okay, coming back to this particular VCEO, so that is the sustaining voltage which is going to be minimum 100 volt. It means we can have a system with 100 volt capabilities, like 100 volt system it is there, it can easily work on. Rest other parameters are almost same. Coming back to the most important parameter which is going to be DC current gain, so that is 5 ampere as well as 10 ampere. So if it is working 5 ampere IC current rating, it can go ahead with minimum 1000 gains, and similar to that, for 10 amperes of IC the minimum current gain will be having a capability of 500. Okay, As you can see, the turn on time and turn off time is going to be 0.9 microsecond and 4 microseconds. So you can see it cannot work like up to megahertz system. So you have to have a system of lower than 1 megahertz frequency, switching frequency. Okay, so that's the understanding we should have. So the system should be I mean less than 1 megahertz capability. Let's say like 100 the system is working with 20 kilohertz or 30 kilohertz, or let's say 100 kilohertz. So these are good choices. Coming back to the electrical characteristic curve, so this is nothing but safe operating area. So safe operating area, what he is saying is, if you are going to have maximum IC current which is up to around 10 amperes, 10 ampere, it means it can work up to VC which is going to be 12 volt. So that's the reason I told you that time. If you are going to increase the voltage rating, similarly the current rating will reduce. Okay, so what is happening, let us say you are going to work with 5 amperes. Okay, so 5 ampere it can work up to around 24 volts. That's the meaning I told you, right? If you cross this one, this is kind of 5 ampere, so according to that the corresponding voltage rating will be 24 volt. So this is how you have to make sure your DC operation will be inside this thick like safe operating area. This is the main understanding. Moving back to next one, test circuit. So test circuit, it is nothing but like suppose we want to test this particular device, then we can have, this is my collector, this is my base, and this is my meter, and we can put one switch. Okay, so this switch can be taken into account, and there is a IB current which is going to excite this particular transistor, and this is how it will be working. Okay, so as you can see, once you excite this particular transistor, this IC will start flowing, and you will see there is a current through RC, that is the collector resistor, and this is the voltage supply that is given for the system. Okay, so this is how the test circuit is working. So it's very simple. Anyway, we do the same circuits. Coming back to PNP type, so PNP type, the transistor will be actually going ahead like this. The collector current will be actually coming out of the collector terminal, and same way base current will be also flowing out of that, and actually the this is VC it is showing, but actually if I see IE, then IE will be flowing like this will be my IE. So IE is actually the summation of IC plus IB. Okay, going back to next one, packaging information is no problem. Let's come down. Yeah, we have mechanical data. So mechanical data, you can see like what is the millimeter, like A, and like maximum. So this is the mechanical data because of this particular device, like length, width, and height. So these are actually very huge device. You will be having a very big package because of the high power rating capabilities and all those things. That's the reason power transistors are bigger, and they have a very high capability of power dissipation capabilities. So this device was actually released in 2007, and it was updated with 2012. So good. Hope you have a good understanding about this particular power transistors, and if you want to utilize, or if you're looking for some power transistor which can be utilized in your particular applications, you can choose one of them. And the thing is, I just tried to explain you what are the things that we have to see into account while selecting a power transistor, whether it is NPN type or PNP type. However, these days there are a lot of advancement and improvement that has happened in the power transistors, and you can have very good transistor part numbers as well in the systems. But you can always start with a fundamental parts from this tip series, which is tip 142 and 147. Thank you so much.